So let's do the next set of 20 sums or 10 sums or whatever it is from integration. Okay, so let me do from the beginning, okay? And the first sum, let me reduce this so that you can see it properly. The first sum is 1 by 2x minus 3 into dx integrated from 0 to 1. I know as soon as I see this, I'll write log of mod of 2x minus 3 by 2 integrated from 0 to 1. So it will be log upper limit 1 by 2 of course can be taken out common. Log 2 minus 3 is log of minus 1 and log of 0 minus 3 is log of minus 3. Okay, so upper limit is with minus lower limit. Okay, and we know that within log there cannot be negative sign, and therefore log of 1 by 3, log 1 by 3 what is it with the minus sign? Okay, so it's a 1 by 2 up. Okay, now if you reciprocal, if you want to get the answer that's given there, obviously if you write minus 1 by 2, because this is when it goes up 3 to the power minus 1, right? So then therefore log 3. So you can, if you want to get that answer, even otherwise this is also fine. That's the first question. So let's go to second question. Integration of a to b x cube into dx itself is 0, and a to b x square into dx is 2 by 3. This is nothing but x cube by 3 integrated from a to b, which is b cube minus a cube by 3 is equal to 2 by 3. So then you get this, and in this if you integrate x to the power 4 by 4 from a to b, so b to the power 4 minus a to the power 4 by 4 is equal to 0. So b to the power 4 minus a to the power 4 itself is 0, which is b square plus a square into b square minus a square is equal to 0. It's not possible for this to be 0, therefore b square has to be equal to a square. So b equal to a or plus or minus. Okay, so then if it's equal, then there's a problem, right? So there can we think that it's got to be equal to plus or minus a, so b has to be minus a. So in that case, if I write that here, b cube minus b the whole cube, which is plus b cube, is equal to 2. 2b cube is equal to 2b cube is equal to 1. So b is equal to 1. And substituting, a can be opposite symbol, so a can be minus 1. So this is the only way we can solve this. There's no other go, right? So let's go to the next question. Third question, integration of 0 to pi. Sine cube x dx. So first of all, when it's 0 to pi, I'll try to use the property 0 to 2a f of x dx. Is it the same of, in that case, f of 2a minus x is the same as f of x? Sine pi minus x? Yes, it is. So 2 times 0 to pi by 2 sine cube x dx. Then you can write this as sine square x into sine x into dx. Then you can write this as 1 minus cos square x into sine x into dx. So t is equal to cos x, dt will be minus sin x dx. So this itself is minus dt. So 2 into 1 minus t square into minus dt. So it will become 2 into t square minus 1 into dt, which is 2 into t cube by 3 minus t. And the limits change when you put x as 0, cos 0, t becomes 1, cos 0 is 1. Cos pi by 2 is 0. So upper limit minus lower limit is 0 by 3 minus 0 minus of 1 by 3 minus 1. So 2 into, it's 1 minus 1 by 3 or 2 into 2 by 3. So answer has to be 4 by 3. We got it. Okay, so let's go to the next question. 0 to pi by 2, 1 by 1 plus root tan x dx. So this is only a textbook sum. 0 to pi by 2, 1 by if you write as root sin x by root cos x, the root cos x will go up and you will have a root cos x plus root sin x into dx. And when you apply the property, this is 0 to a f of x dx can be written as 0 to a f of a minus x dx. Let's use that property. This will also be I, where it will be root sin x by the root sin x plus root cos x. The denominator is going to be the same, so you can add this equation and this equation. These two i's, 2i is equal to 1 dx. You get cancelled, and integration of 1 dx integrated from 0 to pi by 2. So 2i is equal to x integrated from 0 to pi by 2. So I therefore is pi by 4. So let's go to the next question. It's the fifth question. Pi by 4 to pi by 2 root of 1 minus sine 2x dx. I did it in another video also, that the sum is repeated here. You know, as soon as you see this is cos x minus sin x the whole square. So when you remove this mod root and square, it means it's mod of cos x minus sin x. Okay, because it may be plus or minus. When considering this interval pi by 4 to pi by 2, this will become negative, and therefore you should write as sin x minus cos x. So depending on the interval, now you can remove the mod, because you know for this interval it's going to be negative, so we switch this into dx. So this will be minus so integration of sin x is minus cos x minus sin x, cos x is sin x. So the limits, applying the limits pi by 4 and pi by 2, minus cos pi by 2 is 0, minus sin pi by 2 is 1, minus of minus cos pi by 4 is minus 1 by root 2, minus sin pi by 4 is minus 1 by root 2 again. So this is minus 1 minus, if you take the minus out, 1 by root 2 plus 1 by root 2, which will be 2 by root 2, which will be root 2. So therefore answer root 2 minus 1. So let's go next question. 0 to a 1 by root of ax minus x square into dx. So the moment you see this, we'll think of only doing substitution. We don't want ax minus x square, is it? Okay. So ax minus x square. What can I do? Let me think. 1 by, if I take x out, it will come as root x. If I take x square out, if I take x square out, I'm just trying, it will become x. This will become root of a by x minus 1. And what is the use in that? A by x is minus 1 by x square. No, you're not able to get that. So let me think how to do it. Okay. See, I thought it's similar to the textbook sum, but the textbook sum had an x outside. So when you have an x outside and you have a sum like this, you can take an x square in the root outside, it will become, make it x square outside, and you get a minus a by x minus 1. So a by x minus 1 is t, minus a by x square will become dt. It will help, but there's no x outside. So I don't have a choice but only do it as completion of square. So 0 to a 1 by root of something minus x square minus ax. Okay, to write it as this is what is there. To write it as completion of square, I am just doing 0 to a 1 by root of something minus x square minus 2 into a by 2 into x. So I'll have a plus a square by 4. I'll have a minus a square by 4, which can come here. So then 0 to a 1 by root of a by 2 the whole square minus x minus a by 2 the whole square into dx. So now this is like x minus a by 2 as t, dx is equal to dt. How does the limit change? If you put x as 0 to become minus a by 2, and you put x as a minus a by 2 is just a by 2. So it's becoming minus a by 2 to a by 2. 1 by root of a by 2 the whole square minus t square. And this is just a sine inverse of sine inverse of x by a, or sine inverse of t by a by 2. We integrate from minus a by 2 to a by 2. Yeah, so then could I have used any properties? I could not have. F of minus x is, what happens if we put f of minus t? It's still going to be the same, so I could have written it as 2 times 0 to a by 2 instead, right? So if I use that property, then I would write it as 2 times a by 2. So in that case, it will become sine inverse of 2 into a by 2 by a, which is sine inverse of 1, minus sine inverse of 0. So then the answer is 2 into pi by 2, and hence the answer is pi. So let's go to the 7th question. 1 by 4 to 1 by 2, 1 by root of x minus x square to dx. So here again I'm just thinking, should I do completion of square, or should I take the x out? If I take the x square out, comes as x, I'll have 1 by x minus 1, which is of no use again. So therefore I have to think of doing only completion of square. No substitution will help. So something minus x square minus x into dx. So 1 by 4 to 1 by 2. So 1 by root of something minus x square minus 2 into 1 by 2 into x plus 1 by 4 minus 1 by 4 will come here. So therefore this will become integration 1 by root of 1 by 2 the whole square minus x minus 1 by 2 the whole square into dx, which is 1 by 4 to 1 by 2. So if I assume x minus 1 by 2 as t, so if I put the lower limit 1 by 4 here, 1 by 4 minus 1 by 2, the LCM will be 4, so it will be minus 1 by 4. And if I put 1 by 2 minus 1 by 2, the upper limit is 0, so minus 1 by 4 to 0. So the limit is going to change to minus 1 by 4 to 0, 1 by root of 1 by 2 the whole square minus t square, which again is like sine inverse of t by 1 by 2, so 2t, integrated from minus 1 by 4 to 0. Upper limit is 0, lower limit minus of sine inverse of 2 into minus 1 by 4, and sine inverse of minus is plus minus, and so it becomes sine inverse of 1 by 2. And when would sine be 1 by 2 in 30 degrees? So it's pi by 6. Is the answer correct? Yes. So let's go to the next question. 8th question, 0 to 1 x into log of 1 plus 2x into dx. So as soon as I see this question, I know I would like to do integration by parts, which I'll rearrange because I late, logarithm has to come first. X into dx is 0 to 1. Log of 1 plus 2x into integration of x is x square by 2 minus big integration. Differentiation of log of 1 plus 2x is 1 by 1 plus 2x into 2, and the integration of x is x square by 2. 2 and 2 get cancelled, so you get it like this. So log of 1 plus 2x into x square by 2 minus this itself is like x square by 1 plus 2x dx. And can you see that the numerator is greater than the denominator? So in that case, you will take the numerator and divide it by the denominator. So you write 2x plus 1, and you know, if you do it by x by 2, that's when you get an x square plus an x by 2. So minus and minus, so it will become minus x by 2. And to get this minus x by 2, you have to plus 1 by 2, is it? Minus 1 by 2. So when you multiply this with minus 1 by 2, 2 and 2 get cancelled, you get, no, 1 by 4. That's when you will get, because it's already 2x, minus x by 2 minus 1 by 4. Okay, sorry, minus x by 2 minus 1 by 4. So when you change the symbol, remainder is this, a quotient plus remainder by divisor. So quotient is x by 2 minus 1 by 4. Quotient plus remainder by divisor. Okay. So this is my assumption. I don't know why should this sum be so lengthy. It should be so let me go offline for a second, check what I've done. Okay, yeah, so then just identified, yeah, it's a right sum. So quotient plus remainder by divisor, and then you integrate those, you get this and apply 0 to 1, you get 1 by 8 into log 3 as the answer for this part, which is a quotient plus this integration part. What about this part, the first part which we've solved? We have to apply the limits, which is log of upper limit is log 3 into 1 by 2, that's all, and when you put 0 it becomes 0. So log 3 by 2 is the answer for the first part. So log 3 by 2 minus log 3 by 8, so LCM will be 8 into 4, so it will be 3 log 3 by 8, yeah, and that's the answer. So let's go to next question, 9th question. Integration of pi by 4 to pi by 2 cos 2x into log of sin x into dx. Again, I would do it as a integration by parts, or I'm just thinking if it was sin 2x, I would write as 2 sin x cos x, then I can put t dt and all that, but it's cos 2x, and even if I write cos 2x as cos square x minus sin square x, or 2 cos square x minus 1, no, I think I would go for integration by parts directly. So let's try. So let me do this and see if I'm getting the answer. Because it's cos 2x, if sin 2x I would have easily written as 2 sin x cos, that was a textbook sum. Okay, so integration by parts, log sin x into dx, log sin x into integration of cos 2x is sin 2x by 2 minus big integration 1 by sin x into differentiation of, now sin x is cos x, so it becomes cot x into cos 2x integration again as sin 2x by 2 into dx. So this part is done, and log sin x into sin 2x by 2. We have to apply limits, of course, we'll keep that separate. This is cot sin x, which is cos x by sin x into 2 sin x cos x by 2. 2 and 2 get cancelled, sin x get cancelled, it becomes merely a cos square x, integration of cos square x, and you all know it has to be written as 1 plus cos double the angle by 2 dx. So the answer will be x by 2 plus sin 2x by 4, and this part you already have solved, log sin x into sin 2x by 2 with a minus sign integrated from pi by 4 to pi by 2. So let me apply the limit and see. Log of sin 90, sin 90 is 1, log 1 itself is 0. So the entire thing becomes 0, for the first term becomes 0. Okay, upon applying pi by 2, let me go to the next one. It's my x on x by, on substituting an x here, it becomes minus pi by 4 plus sin 2 into pi by 2 is sin pi, so that becomes 0. So you only have one term, and minus lower limit is pi by 4. So sin pi by 4 will be sin 2 into pi by 4, sin 90 is 1 by 2, log sin pi by 4 is sin pi by 4 itself is 1 by root 2 into sin pi by 4 here, sin pi by 2 1 by 2. So okay, that is not a part of log, that's 1 by 2 minus pi by 8 plus sin 2 into pi by 4, sin pi by 2 is again 1 by 4. So where does the lower limit starts? The lower limit starts from, I think pi by 4 was the only one which was upper limit, minus of lower limit, rest of it is all lower limits. So minus pi by 4 minus 1 by 2 log 1 by root 2 plus pi by 8 minus 1 by 4, and a minus pi by 4 plus pi by 8, if we take it as LCM 8, it's minus 2 pi plus pi, so it's minus pi by 8. And let me check what is the answer that he has got. He has got a minus pi by 8, that's fine, yes, so that gives me some hope. And this 1 by root 2 can be written as 1 by 2 whole to the power 1 by 2, so minus 1 by 4 log uh, 1 by 2, and if I can take write it as plus, it will become 2 log 2 plus 1 by 4 log 2, and you still left with the minus 1 by 4, whereas the written answer here is plus 1 by 4. That is my only issue here. Don't you think okay, let's see when I substitute here, it has got to be plus 1 by 4, I think. Yeah, which became minus 1 by 4 in opening the bracket. I think that's the right answer, right? It has got to be minus 1 by 4. Maybe that I have done some copying mistake there while I was writing the answer. Can be, right? I don't think it can go wrong. Sine 2 into pi by 4 is sine 90. Yeah, it's positive. Once you open the bracket, it becomes negative, unless there was this symbol here itself is not positive, it's negative. Let's check that out. Okay, yeah, that itself is negative. Yes, that itself, yeah, when you integrate it's plus, but when you open the bracket it's minus. So then therefore this will become minus, this will become plus, and this will become plus, and it's sorted. Okay, so we got the answer. Let's go to next question. It's the 10th question. 0 to infinity 1 by x square plus a square into x square plus b square into dx. Okay, so then square plus a square. My only thought is to do it as the state board, assuming it as y. Yeah, that's my only thought. So what happens when it is 1 by y plus a square into y plus b square? Normally I'll do it as a by y plus a square plus b by y plus b square. So a into y plus b square plus b into y plus a square is equal to 1. The denominator gets cancelled, so you have something like this. So putting y is equal to minus a square. Let's try what is harm. So this becomes 0. So 1 is equal to a into y is minus a square plus b square, which is b square minus a square. So a itself is 1 by b square minus a square. And putting y is equal to minus b square, 1 is equal to b into a square minus b square. So b therefore is 1 by a square minus b square. So you have an a and you have a b, and you have to substitute it here. And what is a? It's 1 by b square minus a square is a into integration of 1 by, substitute y as x square plus a square into dx, plus b itself is 1 by a square minus b square, integration 1 by x square plus b square into dx. So these are tan inverse 1 by b square minus a square, 1 by a into tan inverse of x by a, plus 1 by a square minus b square, 1 by b into tan inverse of x by b. Is it definite? It's 0 to infinity. So then it's 1 by a into b square minus a square. Tan inverse of infinity, tan 90, right? Tan inverse of infinity will be 90 degree. So it will be pi by 2a plus 1 by a square minus b square into 1 by b into again tan inverse of infinity. So it's pi by 2b. So this upper limit is sorted, lower limit will be 0. So this is my answer. Let me check what I have written here. Okay, that's quite different from what I've got, but let me take out common. 1 by 2ab is common. That's good. Pi by 2ab. 1 by b square minus a square plus 1 by a square minus b square. So when I solve this, you can write it as minus of a square minus b square. If you write a minus here, you can write a square minus b square. So that way you will get a square minus b square to be the LCM. So what? Something seriously wrong. Let me check. Let me go offline for a bit. See, just to recap, I'm just trying to do it as partial fraction. Okay. Yes, and I got A, I got B. Just check, you keep doing it and check your answer with mine and see what is wrong. So you get something like this, right? But the answer what I have here, okay, these are something that I worked out now, but I'm not getting exactly what is required. The required answer I'm not getting. Having said that, okay, you can proceed like this and check out what could be wrong. Okay, and if you can find the fault, and you can still get the right answer, it's okay. But there's another method in which you can easily do this sum. Whenever they give you 1 by x square plus a square into x square plus b square into dx, you just multiply and divide by a square minus b square. Write a square minus b square on the top with x square plus a square into x square plus b square. Add x square and subtract x square will fetch you easy answer. Instead of x square minus plus a square minus x square minus b square, it's like adding and subtracting. Okay, so look at the magic of this sum. If you do it like this, what an advantage. 1 by a square minus b square into x square minus x square plus a square minus x square plus b square by an x square plus a square into x square plus b square, and by x square plus a square into x square plus b square. This and this get cancelled, this and this get cancelled. Sum becomes very easy to solve instead of doing that way. Oh my god, 1 by x square plus a square here integration, and this is common. So you have a 1 by a square minus b square, and this is 1 by b tan inverse of x by b minus 1 by a tan inverse of x by a integrated from 0 to infinity. So on substituting 1 by b into tan inverse of infinity is pi by 2. So pi by 2b minus 1 by a into tan inverse of infinity pi by 2a, and 0 of course will be 0 only. So you get it like this. So then if I take pi outside, I get a square minus b square, and a 2 also can be taken out common. So I'll get a 1 by b square minus 1 by a square. Isn't it the same as my answer that I got before? So it's like a square b square, so it will become a square minus b square. Oh, then a square minus b square itself is getting cancelled. I have a pi 2a square b square, and what is the answer that I've given here? 2ab, what is that? 1 by a plus b, there's nothing like that. I have not got anything like that. Oh gosh, I understood my mistake. Okay, there's no b here because this itself is pi by infinity, tan inverse of infinity. The b doesn't matter there. Here also the a will not come. Okay, so that was my mistake. I hope you understood. So the same mistake is what I've done in the previous method. You can do any way, you still get it the same answer. So then therefore it's 1 by b minus 1 by a. Okay, so when you take LCM here, it will be a minus b, and you get a plus b into a minus b. So that's sorted. You got the answer that is required. I've showed you both the methods. Yeah, so then a minus b, it's a plus b into a minus b. So you have an a plus b here, and you got the answer. So similarly, in the same way, I have made a mistake here also. This it's the same. It's going to fetch you the same answer, no problem. When you substitute here, this a you should ignore because that's 90 degree. Okay, so I've done 10 sums for now. Please practice all these sums. Do it like a test. Take the video and check how if you've done it correctly. Okay.